In this lesson, we'll be exploring two-dimensional plots and how to annotate those plots. Our learning objectives today are to plot lines in a figure with very well-defined line specifications and line properties, to also plot multiple graphs on an axis using the plot command or hold commands, and then also to annotate a figure with title, labels, and a legend. So to explore this, let's start with just using our plot XY. So to explore this, we're going to be using data from problem 210 from our book, and we're going to start by building. So to explore all these features, we're going to be building the plot from problem 210 from our book. So the first thing we want to do is open up our MATLAB, make sure that we have our plotting data.mat in our current folder. We'll open up a new script and we can save this as something like plotting example. And we can save this as plotting example. We'll just be running this script over and over as we build our plots. So the first thing we want to do is we want to load our plotting data. And then let's apply the simple command of a plot XY. So after we load our plotting data, you can see that we have X values, Y values, and Z values. So let's use plot X values versus the Y values, and we'll see what we get. Now by running this command, just plotting X values and Y values, it automatically generated a figure 1, and then we see that we get this curve, which is the beginning of our curve in problem 2.10. And so instead of having the figure generate itself, I think it's best practice to actually specify that we want a figure. So every time that we run this, the figure will open. And so one note about these figures is that if we run this again, we're going to get a new figure. So notice this says figure 2. And so we have two figures that are still open, a figure 1 and a figure 2. So this is where our close all command comes in handy. So at the beginning of any script, we're skipping our header for right now, but this is where we'll have our clear all, close all commands. Clear all will wipe out our workspace. Close all will close any additional windows that are present. Now let's start formatting the line on our plot. And we'll do that by looking at line specifications first. Now, line specifications are going to help us define the line style, the line color, and the marker type. And these are implemented and typed in as a character array these are the ones with single quotes inside the plot command after you specify the X and Y arrays. And we'll do this by choosing any combination of these three specifications, and we'll put them all into the same character array. So for example, if we wanted to have a line, just a solid line, we would say a dash, and then it has that it's a red color, and then we have our markers as O's. And as we run this, we'll see now that we have exactly what we wanted by cramming these three specs within that same character array. These characters can be in any order, so we can define our red first, our solid line second, and our O's as our markers. And also note that if you leave off the line spec, so if I remove my solid line marker or my solid line specification, in that case then we get the individual points. And this is really handy for showing data that you collect, which is typically presented on a plot or a graph as individual points, and then you might put a curve fit that's a smooth line over top of it. So now remember, this is the plot that we're after. And right now we're looking at our Y sub X, because we did X versus Y, which is a thick blue line. We have red stars with a white inside. Our thick blue line is a dot dash. And so we can get some of this done using the line specs. So as we look at our line style, we're going to choose the dash dot, our color will be blue, and then our marker type will be the 5-pointed star. So let's put those in. So it's a dash dot, our marker is a blue, and then we have a 5-pointed star. You can see that as we run this, we're getting somewhere. We get those specifications that are here, but we still have more that we need to do. And so that's when we're going to turn to our next level of features that we can specify with these lines, and that's using the line properties. So here, the format for line properties is that we're going to have our plot, our x versus our y, and then we define our line specs. We've already done that, and now we can start tacking on these optional properties by adding 2 different elements into the plot command where we specify a property name and then a property value. And so in this table we see that we can change the line width, marker size, our marker edge color, our marker face color, and then the color of the line itself. And in the property values, there are some that can be numeric, such as the line width or the marker size, or any of these with the colors using an RGB, or they can use the color specifiers that are coming from the line specifier table up here. So simply by giving a character array of R, G, C, M, K, W, B, and so forth. So let's take a look at our plot and add what we'd like. So first we want to do a thicker line, and the property that we'll use here will be our line width property. And so our line width, we'll specify this to be 1.5. We'll run it. And this is the one that I honestly end up using the most in practically every plot that I create. I'm going to make the line a little bit wider, just easier to see, more visible to your user. Next, let's deal with our marker size. Our marker size here is 14. So we'll take our marker size, add it to our plot, and then specify 14. We have much larger stars now. Next, let's deal with our marker edge color. We want this to be red. You can see here that we're starting to run out of our window, and so we want to add just an ellipse at the end, which tells us to move to the next line. Our marker edge color is going to be red. And we want to fill in the face of each of these markers with the color white. So back to our marker face color. We'll add this as a specification and then set it to be white. Right, now let's compare that to the plot that we're after, and you can see that we're getting somewhere. We've now properly formatted our y as a function of x, but we need to add to this a z as a function of x. So let's talk about how to add multiple graphs on the same plot. And MATLAB provides several ways to do this. The 2 most common ways are to use the plot command, and in this use multiple pairs. So x and y as a pair, u and v as a pair, and then t and h as a pair. And this command is going to create 3 graphs on the same plot, a y versus x, a v versus u, and then an h versus t. And always each pair of these arrays, they have to be the same length, and then MATLAB automatically plots the graphs in different colors for easy identification. Let's go back to our MATLAB window and let's try that out. So comment this. We'll need this line, these 2 lines in just a moment. So let's do our plot, x values versus our y values, and then our x values, and then z values. Run this and you can see that we now have our 2 plots, and and they are in the specified colors that MATLAB wants, or that it goes through, in which we have a blue plot and then kind of an orangey colored plot, but we've lost all of our formatting because we removed it from our commands. And so we can add some line specifications to this. So in our first plot, which was our X and Y, we did a dash dot, and it was blue, and it was a star. And then we can add the specification here, which is going to be a blue line, and then we have green squares. So for this, it would be blue dash and S for squares. And you can see that we've run this, we've got our blue lines, we have our squares and our stars. But what we're missing now are our line properties. So that's one big disadvantage that we have in this type of command. There is an advantage in that we can squeeze everything into one line, our X and Y, and then get our line specifications. But there are two disadvantages. First is that it's starting to get a little bit cluttered. It's a little bit hard to read now that we're putting these multiple lines within a single, or multiple graphs within a single line. But the major disadvantage is that we can't apply line properties with this type of command. So there are several ways to add these properties that move us into what's called object-oriented programming. But I want to go over what I consider the most straightforward way to add these, and that's using the hold on and hold off commands. So the process of using hold on and hold off goes like this, is that we can delete this line. You first want to plot the first line that you want on the plot. And we'd already defined this with our red stars, with our white faces. And then following this command, type in the command hold on. And what's going to happen here is that it's going to keep the figure window with the first plot open, and it includes the axis property and formatting and any formatting that was done. And it's going to hold that steady. And then what we can do is we can apply our next graph, which is going to be the X values and then the Z values. Our line specifications are blue. It's a normal line, and we're using our square. Then we're going to add our marker color, which is going to be the edge color rather, which is going to be blue, and then our marker face color, which is green. And after adding these line properties, we'll take the hold off. And this should provide us a plot in which we have the proper line properties, line specifications for both of our lines that are now included onto the same graph. And now in our next step, we need to determine how to annotate these plots. Really, plots are useless if you don't know what the data in the plot actually are. So every time you create a plot in a class or for a project, you must annotate the plot. And so you can see that the normal way is to have no labels on the y-axis or the x-axis or a table. So let's add each of those. The commands for these are X label. We're just going to put X values in a character array. Y label. And here we need to have its y as a function of x or z as a function of x. It's also common to put units in here, so I'll just put a placeholder for the units. And when we run this, we see that our X label is applied to the horizontal axis and our Y label is applied to the vertical axis. So let's add a title now. And that's simply using the title command. Also going to be adding a character array. And our title is, this is problem 210. All right, let's compare that to the plot that we were after. And we're almost there. So the last thing that we have is that we have our y-x or z-x, which is specified on the vertical axis, but we don't know which one is which. Now, we've worked through this plot ourselves, so we know that this is our y as a function of x, and then the blue with the squares is our z as a function of x. But we really need to add a legend, which is going to help your viewer, your reader, distinguish what's what on this plot. To do this, we use the command legend, and we have two different lines that are on here. Our first, we said, is y as a function of x. Our second is z as a function of x. And what's happening here is that we need to put these in the order in which they are plotted. So our first plot command was x, y. Our second plot command was x, z. So the order that we put our legend will be y as a function of x and z as a function of x. And then that will associate each of these labels with the correct graph that's on the plot. One last useful item in annotating plots is the text command. And so the text command allows us to place text anywhere on the plot. So let's say that we want to place text within this region here, which is going to be an x value of about 0.2, a y value of -1. And in the text command, we're going to specify that, so 0.2 and then -1, and then we can type whatever text we'd like. So let's just fill up this blank space with text. And this is really helpful for pointing out different parts on your plot. Now, a different way to place text onto a figure is going to be using the gtext command. And you can see what I did is I removed the coordinates. So if you don't know the coordinates that you want to use and you just want to add an annotation, when we run this, then you can see now I have a cursor, and wherever I click is where the text is going to be. All right, so that concludes our introduction to two-dimensional plotting and annotation. Every time that you create a plot or a figure, like I said, for this class or for a future class, it's really important that you go through each of these steps to communicate all of the information appropriately to your professor or to your reader. Especially want to emphasize labeling each of your axes every single time, adding a title every single time, and then these text features are really nice for, like I said, annotating your plot, helping your reader understand exactly what you've done.